Hello everyone, welcome to our new episode. In this episode I would like to talk about utility maximization for perfect complement case. Alright, so the utility function is u of xy equals the minimum of ax comma by, where a and b are some positive real numbers. As usual, px, py are the prices for good and I is the income. All right, so how do we solve this maximization problem? So to maximize x and y in R plus, all right, so we choose x and y to maximize the utility function while we're maximizing the min function, all right, subject to the standard budget constraint, pxx, pyy equals income. All right, so we don't need to write less than or equal to income because the min function is an increasing function, meaning as you consume or increase x and y, while the utility value will also increase. Very well. So we do not write the Lagrangian function mainly because the min function is not differentiable, all right? So therefore the first order conditions are not going to be well defined. So how do we solve this problem? Well, as usual, if you cannot use the Lagrangian, you should always draw the indifference curves, the budget line, and compare the slopes. All right, so this is the budget line graph, x on the horizontal axis, y on the vertical axis, and this is the indifference curves graph. So the budget line is a fixed straight line, just one. So here the x-intercept is I over px, and the y-intercept is I over py. So the straight line connecting these 2 points is what we call the budget line. And the slope is minus px over py, as usual. All right, there's no surprise in the budget line. Well, what about the indifference curves? Okay, so here we already mentioned, talked about the indifference curves of a perfect complement scenario. But if you remember, the idea is the following. Oops, sorry. It's the min of ax by. All right, so we set this equal to some k constant, all right, which is a positive real number. So what does that mean? Well, we are basically trying to find all the x's and y's where the min of ax by is going to be equal to k. All right, so our starting point is usually the point where this corner point, meaning the ax and the by. Remember, I am trying to pick the minimum of these two. I don't know a and b values here. It's just a generic form, but doesn't matter. So what that means is, like, if ax is equal to k and by is equal to k, well then the minimum of ax and by is going to be equal to k, right? So therefore, whenever x is equal to k over a and y is equal to k over b, I will have the value k. So let's suppose a over k is here and k over a is here, right? Sorry for my mix up. So k over a is here, and let's suppose k over b is here. So this is the first point. All right, so let's color the indifference curves on blue rather than black. All right, so this is my first point on my indifference curve. Very well. What else? Well, I also know that if ax is equal to k and by is, for example, greater than k, well, I still have minimum of ax by equals k, right? Because I always take the minimum values. So this guy is greater than k, so the minimum of, ax by is just, the k. So the utility function is going to give me the k values. So that means whenever x is equal to k over a, and y is greater than k over b, right? I will have exactly the same level of utility. So y greater than k over b, while x is equal to k over a is basically all these points. Very good. What else? Well, once again, this time, if symmetrically, right, symmetric to this argument, if by is equal to k, but ax is greater than k, well, then I have exactly the same thing. This guy is greater than k, this guy is exactly k, so the minimum of these two terms is nothing but k. So that means y is equal to k over b and x is greater than k over a. All these points are going to give me utility values of k again. So what are all these points? Well, y is k divided by b, and all the x is greater than k over a. All right, so I have this L shape. By the way, you definitely should check, but whenever, these are not all the possible cases, right? Ax equals k and by less than k, for example, right? But the problem here is when ax is